Hey there, Math Moment Makers. John here from Make Math Moments, and I want to share with you this in this video a common question that we get, and it's something that definitely is on teachers' minds, and that is, I guess let me just show you here on our web page here. Like on our tasks page, we have lots of tasks for you to use in your classroom. We've got teacher guides in there, and we've got ideas on, say, rates and ratios and counting and lots of different tasks, ranging from grades 3 through 10. So there's lots there to choose from. And the nice thing is we don't put the grades on there because we think that you can stretch those grades depending on what you're teaching and topic. But we often get a question like this, John, and Kyle. It's easy to make a real life context rich problem on rates and ratios. That exists so many places. But how do I make a curious, engaging problem, or where can I get curious, engaging problems for more abstract topics like solving equations, or the distance between 2 points, or trigonometry, and some of the rules that we have to go with that. And so this video is just kind of a quick kind of preview on what you can do. And what you can do is actually is something I shared in one of our videos here on the hero's journey. I just want to kind of bring that up from one of our previous videos. I'm kind of showing you right there. But if I bring this slide over about the hero's journey, we talked about this curve and how this curve can be helpful when you're planning problems. And the idea here is that you're building tension, or you're building like struggle, because on a hero's journey, all of those heroes that were in our favorite stories, they have to go through this struggle part. They have to battle the forces of evil. And that's where we talk about staying curious, and that's where we're the guide that steps in. Like, we're the Obi-Wan Kenobi that helps the Luke Skywalker kind of see what to do. And but the Luke Skywalker has to go through that struggle so they can attach value to meaning or learning. That's in that other video. So we want to know more about that, head on over there to check that video out. But the idea is that we're going to put kids in situations where they are trying to be curious and use their thinking. I think that's the biggest thing that is different from our lessons now than what we were doing before, is that we're trying to get kids to think instead of just mimic or memorize. And so if we can put our kids in this kind of thinking position where they're productively struggling, we might be able to consolidate later at the end instead of at the beginning, to kind of tie up loose ends, give them strategies then. Maybe like all of a sudden formulate new procedures at the end instead of at the beginning. And so I guess I'll show you a couple of examples how you do that, because that's really what we're doing. We're doing that through the curiosity path that we've talked about many times. Is that the best way you can get to making math moments that matter and avoiding rushing to algorithms is by following the curiosity path. And the best way to create that struggle is to do these four things, which is, in the biggest one I'm going to focus on here in this video, is about withholding the information. If you could hold that information back, you can create that struggle that students are going to go through that might bring out efficiency, but it also might bring out strategies that they are going to try, and you're going to kind of tie up. Hey, did you try that strategy? We're gonna move through this. What did you try? What did you try? Let's consolidate. How are your strategies same? How similar? And how are your strategies different? So the biggest part is, by withholding information, you can get students to think, and that's very much different than what I taught for many years. So let me just jump into an example here. Like, if I was teaching the distance between 2 points on a graph, right? So this is a very common skill that we teach here in Ontario in the 10th grade, which is kind of, sometimes you can do it in the 9th grade, but it's really Pythagorean theorem. But we present it in this way, like right here on the screen. Like, this is the way I would just say, okay, today we're going to learn about the distance between 2 points. And I put this ugly formula up on the screen and say, here's the formula to find the distance between 2 points on the Cartesian plane. And then I will show you now how to do that. You might show them like a graph like this, and then you might say, okay, I'm going to show you the distance between these 2 points, and I'm going to plug it into the formula. Like, that's what I used to do that, and I think that's still happening a lot. But it's like, that's a very abstract type problem, and how can I like mix that up? How can I I make that more curious? How can I get more engagement out of this skill? This is a common problem we teachers want to know. Like, how do I make these curious problems, but still have to teach these abstract concepts? And so the biggest thing is, can we withhold information so that we can create some struggle with our students? And actually, when I say struggle, I really mean thinking, right? So here's what I did. I showed you at the bottom, because that's actually when I introduced, in this particular lesson I'm showcasing, the formula. And it was because we started way back here and we said, hey, look at how much information I have stripped away here to create a little bit of thinking, a little bit of notice, a little bit of wonder. We have to go, okay, what is the distance between these 2 points? Like, notice this is an old slide, because if you went to, this is a Desmos screen. This is an old, if you go there now, it doesn't look exactly like this. But kids are going to be like, well, what do you mean? Like, we need to know more information. It's like, exactly. We now need to ask that question. What would you like to know? Like, what if I said, find the distance, how could you do that? And kids are going to say, let's get a ruler out. And I said, well, what happens if I did this instead? And I presented this grid. Could you find the distance now between those 2 points? And kids are starting to formulate plans and strategies. And let's listen to those strategies, because that tells you a lot. And so eventually somebody might come up with like, yeah, but I might be able to count, but maybe I can use the Pythagorean theorem here, but will I know the scale? Like, how do we know that each grid line is 1 unit long? So let's give you a little bit more information if you want that scale. So we can present this. And now how will I do that? And when I did this with my students, kids immediately were like, okay, because they were already thinking of a plan along the way. And so kids immediately went to the Pythagorean theorem. They counted 3, they counted 4, they built the Pythagorean theorem right there and solved for the distance there. And so I said, okay, well, what happens if I took the grid away, right? So if I can't count. And so we went through this problem. But remember, the biggest idea is I took information away and we slowly added it back, but we made our kids think, right? They're thinking, and I'm not just showing them how to do this. My students are doing this on their boards or on their walls. So that's an important distinction here. It's like, how do I create curious, engaging moments? It doesn't look the same as those context-rich problems sometimes. It can be very non-contexty problem, like this one here. But the idea is, what can I pull away so that my kids ask questions and wonder and notice, and then start to develop strategies? That's what I'm doing in my senior level classes. That's what I'm doing in my classes that we have to teach abstract concepts. I really want thinking here, and putting kids into puzzling situations will make them think and be more curious by nature. Kids don't need context always to be curious enough to solve a problem. Kids are playing video games all the time, like Candy Crush. It has no context whatsoever, but there's a lot of going on in there that we have to do some thinking that you want to do that next stage. Like it doesn't have to be context to, like a real life context, to all of a sudden make kids want to solve problems. It's about this lack of information, and then slowly bring the information back. That creates anticipation for students to want to go to the next spot. Like there's natural curiosity in there. So notice we did some Pythagorean theorem again on there, and like I just kept kind of changing the situation here. I'm like, oh, wait a minute, no, like I meant to show you this problem here, and then I said, okay, well, what about this? Like, why don't you find the perimeter of the triangle here? And kids are drawing Pythagorean theorem all over the place. And then now, once they've practiced it, once they've kind of developed this strategy, now let's try to generalize it. And that's where they came up with this. Like, they can generalize this formula after they've really solved this problem by thinking, right? By thinking. And we created that situation by withholding information. So if I show you that curiosity path one more time, we can really create memorable moments in any of our classes, senior classes, junior classes, any abstract concepts, by following this kind of withholding information, because it creates anticipation for us to want to figure out what's missing, right? There's a missing element. A couple other I'm just going to kind of run through a couple other examples. Like if I went to a senior class and I wanted to do transformations of trigonometric functions, I'm putting them in situations where they don't know things. There's an information gap, and I'm asking them to think and solve problems here. Desmos does a really great job of that. some of the pre-made Desmos activities. They're building that idea into all of their problems. Definitely check those out. Here's one I built here, and I just had kids. Okay, here I've got this kind of base function. Now you got to type in a function here and be wrong a whole bunch of times until you're right, and try to match that function right there. And then we amp it up a little bit and have them target match these problems. And notice they're doing some thinking along the way instead of me just showing them, right? I'm pulling information away, not giving to them, and then we slowly bring it back in. Here's another Desmos activity that I'm loving these days, which is called puzzling it out, and has to deal with geometry and angles between parallel lines and triangles. What I love about this problem, this series of problems from Desmos, is it definitely makes kids think, and it's very abstract, right? There's very abstract, but normally you would just tell kids these rules. But the beautiful part about this is it makes kids really think, what do I need? Like, what would I like to know? What angle would I like to know so that I could then solve this in the least amount of information possible? Like, I want information, but I want the least amount of information possible. So if I click this one, it tells me it's 138, and now can I fill in the rest? Kids might say, well, maybe I can't. Some kids will, some kids won't, but then you get to have this great discussion of, do I have enough information? Because that's really a big idea on solving problems in geometry, is like, what information do I need to go through this route? This is my plan, how do I get there? I need certain information. Do I have enough? And sometimes that's the biggest problem and the biggest struggle when going through geometry type problems. And so kids will decide, do they have enough, and then fill in the rest. And so you get a problem like this, and you click it and say, okay, did I click on that one enough? Or which one should I have clicked so that I can solve this in the least amount of, given the least amount of information? So that is one of my favorites right there, because it's withholding information and then slowly bringing it back in, and it creates that information gap. So in summary here, if I go back to this, like, how do we create good, engaging, curious problems when we have abstract concepts? I don't try to fit in context. Like, I don't try to bring in these contexts that don't work just to make them more curious, because it's real life. I try to put my students in situations where we withheld information and we're now kind of playing or struggling or puzzling out a situation, and then we develop strategies around that. It doesn't always have to have context. So that was it. I just wanted to share that strategy or that idea with you, because I think that's a very common question we teachers are asking. I do want to point out that we do have a full course over in the Make Math Moments Academy on converting textbook problems into curious questions. We go through a lot of these ideas because textbooks got a lot of questions that we can use and are pretty good. So how do we just convert them? And we use the curiosity path to do that. Say thanks very much. If you haven't already subscribed to our YouTube channel, please get over there and subscribe. And if you're watching this on Facebook, hit that little bell so that you know when we go live. But take care for now, and I will see you soon.